Hey folks, so Science Journey Part 2, where we left off, I was going into my last year of med school and had gone from really pursuing science as kind of a resume thing to look good in order to get into med school to finally, within med school, getting ownership of a really cool project, finding techniques in neuroscience that I just found fascinating, um, and feeling like I had really uh, built something and gotten results. That feeling in science is just indescribably satisfying. Um, when you feel like you've really, some people get it from like discovery. Um, and while I think my kind of catch fire feeling was less about the discovery and more feeling like I had built something. I had built this ePhys rig in order to get these um, intracellular single neuron recordings from this specific brainstem nucleus I was studying in epilepsy that had not been studied in this way before. And it just made me feel real. It made me feel like I wasn't just faking it or just, trying to get another gold star on the resume. It made me feel like I was really doing something, really probing into information that didn't exist before I got to look at it. So that was just a real um, turning point for me in how I thought about science into a wow, no, this is something interesting, fun, rewarding, and just fun, something that I liked to do and wanted to keep doing. So um, I I had some success. I can't emphasize enough how valuable it was to have a great supportive mentor who told me when he appreciated the work that I did and when he felt like I did something important, said, told me that. It just helps a lot when you're in a mentee mentor situation to have a mentor who is supportive and who tells you when they think you've done good things. I was then applying for neurosurgery residency, and even though the actual publication didn't end up coming out until after I finished medical school, um, the the support of my mentor while going through the residency interview and match process was invaluable. Would say, that he thought that I had what it takes to be a scientist. That was just something that gave me a lot of confidence, and I know it counted for a lot when I was applying to these really competitive residency programs. Finished medical school, went into neurosurgery residency, and I was, really excited about a lot of things, but neurosurgery residency is really hard. You're really busy. It's really difficult to do like basic science type research early on in residency. You just have not a lot of free time. I went to a very academic, still go to a very academic program where we need to be doing research, but it's mostly clinical research, talking about neurosurgery and things related to neurosurgery. Um, but my my basic science um, had to kind of, you know, be put on hold for years while I was in my first few years of residency. Um, and that can be really difficult in science to kind of not be in the lab for a while. It, can make you question, oh, am I ever going to be back to it? Am I going to fall behind? Are the techniques and, strategies I learned when I was in the lab doing science, are they still going to be relevant if I were to go back into it? So my program at UCSF, we have our 5th year of residency. It is a pure research year. Those 12 months are held aside. We don't have any call responsibilities. Our job during that year is to do science, to do research, and to be productive in that short period of time. A year is a relatively short period of time in science. And our job during that year is to get something, to produce something, to get something started that we could potentially continue when we finish residency as a path towards being a physician scientist. We're encouraged to look towards that path. There's a lot of physician scientists at UCSF neurosurgery. It's one of the reasons I wanted to come to this residency. I was introduced to a young PhD scientist who was just a few years into starting his own lab, who had already been really productive, who was doing some very cool advanced genetic techniques, and I had no history in genetics at all, but I wanted to learn. I wanted to learn something new. I was really interested in electrophysiology. I was really interested in epilepsy, and as a career, I was interested in studying epilepsy and epilepsy surgery. It's a neurosurgical disease, and I wanted to see if I could learn some of these new genetic techniques like single cell, single nucleus sequencing to incorporate that into my skill set. I worked with this new mentor to come up with a project plan. We applied for and got some funding to do the project that he and I came up with. When we were doing some of the early experiments, he had some high-density multi-electrode arrays, these cool electrophysiology tools in his lab that other people had tried to use and hadn't necessarily been optimized for the types of neuroscience questions I was looking at. And he suggested basically that I try something with them. Just a really open-ended question of like, hey, we have these tools. I know you're thinking about doing this genetic stuff, but maybe you should see if you could get some of this other electrophysiology stuff to work. I know you've got, some history in that. I started using these, and I got some really neat initial data. As again, this is just a lot of these things feel like luck. I thought it was interesting. I tried it. I got it to work a little bit. The data that it was giving me, it just was neat. We were able to record from a lot of different neurons at the same time in these very specialized tissue slices, and it was visually enthralling the way the data looked. To be able to see all these neurons that are firing at the same time caught my attention. We went back and forth about what I could possibly do next and how this might be related to other projects I was thinking about. Little things kept working. It's not like everything kept working. It was still very difficult, but it was fun. I was around a lot of interesting, curious people in the lab, grad students and whatnot. who are neat to work with and very helpful, really great to bounce ideas off of. We got some great data, came up with a plan, and again, just like in my medical school project, where at first the project I thought I was going to do wasn't quite working right, and then I had to change horses midstream and start something new. I had originally proposed doing this one type of experiment, and then this other technique kind of came along and kind of started working. And so I had to make the decision, how much time do I want to put into this, right? And we talked about it, and it just seemed like this was the right path. And we just said, you know what? I think there's a good idea here. And so went for it. It was very much learning a new technique, new types of tissue that I was studying. It was just so much fun. And there were so many questions to be answered. And it was, it was hard. It was challenging, after the initial, good preliminary data, there was kind of a lull where things didn't work for a while, and I was, going over and over and trying to get it to work. And I got linked up with some other collaborators who were also incredibly helpful from other labs. It was this rolling stone of something working and then, coming up against a roadblock, and then something else working and coming up against a roadblock, and things started working. I had, again, that same feeling of, oh my gosh, like, I did it. We did it. We were able to put together this really complicated project. It was working. It was giving us the data we were expecting it to give us. And it was just the coolest thing. It was so satisfying. And I got to work with so many different interesting people. It became just a really great project that, hopefully will be published pretty soon. I think is going to make a pretty big splash. All of a sudden, the path towards what I should be doing next and next and next, and how I could continue this as a career in science, to ask more questions and get more answers. It all just became really clear what those steps were. It wasn't clear at the beginning. A lot of these bricks just kind of fell into place to make it clear. And that brings me to where I am now, nearing the end of residency, but having had this kind of windy path into science that has, I think, given me a lot of different skill sets, taught me how to work with a lot of different types of people, how to work with and manage a team. I just love it. I want to like my job, and I do like my job. I love my job. I love neurosurgery. And over time I realized, I love science too. And I have fun doing it. And those two jobs they go well together. That is kind of how I came into my, current path to being a neurosurgeon, physician, scientist. Some parts of it were windy, some were less windy. The mentors I had over the years were critical in supporting me. I had the advantage of being in supportive academic institutions where there are a lot of resources available, and a lot of other interesting folks around with good ideas to talk to and bounce ideas off of, that just made it a really fertile environment for doing science and learning about science. That's my general science path. I've left out a lot of little holes of the other things in life and neurosurgery, etc., that came on in between. But that is, in general, how I got on my path to being a scientist, a neurosurgeon, physician scientist. So if you're thinking about science and you maybe haven't been thinking about it your whole life, this is my story, and I hope it gives you ideas of, what might be interesting for you.